Hi, this is Alex from devstories.eu, Snowflake and Snowpark Python, Episode 1 of 17. The biggest bottleneck in big data is rarely storage. The real friction happens when you have to move massive datasets across the network just to reach your compute layer. The Snowflake architecture completely bypasses this problem. People often assume Snowflake is just an on-premise relational database lifted and shifted into the cloud, or a traditional Hadoop cluster you have to babysit. It is neither. Snowflake is a fully self-managed service built natively for the cloud. You do not install software, you do not configure hardware. All maintenance, management, and tuning are handled for you behind the scenes. To understand how it achieves this, look at its hybrid architecture. Snowflake combines a shared disk setup with a shared nothing setup. In a traditional shared disk design, all compute nodes access one central data repository. In a shared nothing design, each compute node has its own local chunk of data to process. Snowflake takes the best of both. It keeps a single central storage repository accessible to all compute nodes, but it uses independent, massively parallel processing clusters to run the actual queries against that data. This hybrid model breaks down into three distinct layers. First is the database storage layer. When you load data into Snowflake, it does not just dump raw files into a cloud bucket. It reorganizes that data into an internal, optimized, compressed columnar format. Snowflake manages all aspects of how this data is stored. You cannot access the raw storage directly, you only interact with it through SQL queries. The second layer is query processing. This is where the work happens using what Snowflake calls virtual warehouses. A virtual warehouse is simply an independent compute cluster. Because compute is strictly separated from the central storage layer, multiple virtual warehouses can query the exact same data simultaneously. They do not compete for resources and they do not lock each other out. Here is the key insight. You can scale your compute power instantly without moving a single byte of data. Consider an end-of-month financial report that requires massive data aggregation. Normally, you might have to migrate tables to a larger server to handle the complex workload. In Snowflake, you just spin up a larger virtual warehouse, run the heavy report in minutes, and turn the warehouse off when you finish. The underlying tables never move. The third layer tying everything together is cloud services. This is the brain of the platform. It is a collection of services that coordinate everything across the system. It handles user authentication, manages infrastructure, parses incoming queries, and optimizes execution paths. It also manages metadata, tracking exactly where specific pieces of data live in the storage layer so queries can run efficiently without scanning everything. The most powerful takeaway is that in Snowflake, performance scaling is just a toggle switch on the compute cluster while the massive data tables remain completely stationary. If you're enjoying the series and want to support the show, you can find us by searching for Dev Stories EU on Patreon. That's all for this one. Thanks for listening and keep building.